Module 12.1 Indefinite Integrals of Trigonometric Functions. Objective: determine the indefinite integrals of trigonometric functions. Just as multiplication has division, addition has subtraction, and squares have square roots, there will generally be an inverse function to any function. For the derivatives there is the integral, and if we are allowed to take the derivative of trigonometric functions, then there will be a path to return to the original function. Here are a few important trigonometric functions that we need to take note of. Okay, we have the integral of sine, cosecant squared, and secant. We have the integral of cosine, the integral of secant squared x, and the integral of cosecant x, cotangent x. Okay, let's see how we can apply these. In example 1, we are taking the integral of sine x dx, and straight from our definitions we're going to get minus cosine x plus the constant. And this is just straight from our definition. This is the integral of the first one. Okay, let's look at the second one. We have the integral of sine x tangent x dx. Once again, from the definitions, we can get this, that this will be equal to secant x plus the constant. So just using our definitions, these are pretty straightforward problems. All right, in example 3, this time we're going to deal with the composition of functions. So we're going to have to use u substitution. And the easiest thing for us to u sub out is this bottom. Okay, let's let u be equal to 7 plus sine x. And that would make du equal to cosine x, because cosine x is the derivative of sine x, and if you take the derivative of 7, that doesn't give you anything. So we have cosine x dx, and then if you divide by cosine x on both sides, that will give us that dx is equal to du over cosine x. Okay, so now let's go through and let's substitute some stuff out. So that will give us the integral of the top, the numerator, cosine x, over u, which is the denominator, and then dx is equal to du over cosine x. And look how nice that is. That's going to end up canceling these out, which will give us the integral of 1 over u du. Alright, now that that's occurred, then the integral of 1 over u du will be equal to the natural log of u plus the constant, and then we can go back in and substitute our u out. So that'll be the natural log of 7 plus sine x plus c. And we have now taken the integral of a composition of functions. In example 4, we're taking the integral of another composition of functions, this time with a trig function. Alright, so in this case, we are going to let's get this inside out. So let's let u be equal to x over 8, and that would mean that the derivative of u is equal to 1/8 dx. Alright, and if that's the case, then we can multiply by 8 on both sides, so dx would be equal to 8 du. Alright, now that we've got that, let's rewrite this one. So that's going to be the integral of negative 1/3 cosine of u, and then dx is equal to 8 du. Alright, and so now I can pull the 8 and the negative 1/3 out, and so that will be negative 8/3 times the integral of cosine u du. And then using our definitions, we know that that's going to give us negative 8/3 sine of u plus c. And then we're going to replace our u for the x equivalent, so that would be negative 8/3 sine of x over 8 plus the constant. And we have now found the integral of another composition of functions. Okay, and the last one, we're going to do the same thing. I'm going to go through and rewrite some of this mess. So let's see, we've got the integral of 16, and let's let u be equal to cosine x. And that would mean that the derivative of u would be equal to negative sine x dx. Okay, So now that we've got that taken care of, and if we divide both sides, that'll give us that dx is equal to negative du over sine x. And so we're going to rewrite this now as we're going to let u be equal to cosine x, so that'll be u, and since it's the cube root, we can write that as u to the 1/3 power using our exponential rules, and then sine x, and then we're going to trade out the dx and write it as times negative du over sine x. Notice that in this case, the sine x's are going to cancel. And also notice that we can take the negative, which goes with the du, and the 16 and take it outside. So that's going to give us negative 16 times the integral of u to the 1/3 du. And now we're looking much better. So that would be equal to, all right, negative 16. And we're going to use our power rule here. So that's going to give us u to the 3/3 plus 1/3, which would be 4/3 divided by 4/3 plus our constant. Okay, and then I'm going to flip the 4/3, so that would be equal to negative 16 times 3/4 u, and we can go ahead and put our cosine, so that'll be cosine x, and that is cosine x to the 4/3. Okay, notice that and then we need to make sure to put our plus c. Notice that our 4 and our 16 will cancel, which will give me negative 12. And then we can write that as the cube root, because 4/3 power can be written as the cube root of cosine x, and since it's to the 4th power, plus my constant, and we are done.